Hello, my name is Carla. I'm from the Instituto Militar de Engenharia, and it's a joint work with, no? The cable? Oh, it's back. Okay, luckily. With Jonathan Nogueira Gois, Eduardo Antônio Barro da Silva, e Marcelo de Melo Perez. What we are going to present is a fusion between the infrared data and visible light data. And why we're doing this? Because sometimes when people do video fusion, they disregard the motion information. So the temporal redundancy is not taken into account. So in the top left side, we see the visible light video, just a frame, and on the right-hand side, we see the infrared, and there is a guy in the shade of the core. He's sitting down, that you don't see on the left top side. In the bottom, you see both information. So what we're proposing is to do a motion compensation, temporal subband decomposition, video fusion, incorporating motion information. Why don't we did in the motion compensation block-based information just this? Because when we do motion compensation or motion estimation block-based, the boundaries, the high-frequency components, the discontinuants are not very well represented. So we are going to do a full resolution in band motion compensation using temporal filtering. What we do is, first we do the block-based that we are saying that's not good, but just to guide us, you know. We use very small block, a 4x4 block with fractional pixel accuracy. And in a nutshell, it's as if the pixels in each frame are aligned by motion compensation prior to filtering, okay? So we do the visible light sequence and the infrared sequence. We do the temporal decomposition using two filters, the HAR and the Cohen-Dobeschi Favot 5.3, also known as Legal 5.3. And we do the high band and the low band, and we split in high band and low band, and we perform the fusion with a temporal fusion rule. That's a very, very simple fusion rule, not to mask our scheme. And to do so, the temporal decomposition, we use the lifting scheme to allow the perfect reconstruction. So we do the prediction step, the P, and the updated step in the odd and even sequences that they are the odd and even frames. So the results are, we used 6 different data sets, and we compared our results with 5 different other video fusion methods, sorry. And we just lost in 2 data sets and using 2 different metrics. We use 1, 2, 3, 4, 5 different metrics to how can I say, to see if our method is very accurate. So I'm going to show you 2 videos. The first one comparing on the left side is the Cohen-Dobeschi filter. If you can see there is a ghost behind the man. On the right side is the HAR filtering. There is no ghost. And in the back, everything is okay because it's too far away, but the objects closer to the camera is where we have the most of the problems, like this. There is a ghost on the left-hand side of the Cohen-Dobeschi, and in the HAR, we don't have this. So the next video shows on the left-hand side, the guys are hidden behind a smoke screen. One guy has already passed by. On the right-hand side is the visible light sequence, and on the bottom is the fused sequence. So we can convey both informations with a very simple rule and spatial alignment, temporal spatial alignment. Sorry about that. Well. Almost there. Still have time. Okay. So the conclusion is that the diffusion has a good quality performance. The spatial temporal alignment was very good, not only frame by frame, but when you play the video. And the texture that is conveyed by the visible light sequence is preserved, as well as the infrared information. We have a website with our results, as well with our GitHub, the link to the GitHub with our code. Okay, thank you very much.